Hello students, welcome to part 5 of tablets. In this video, we are going to study about characterization and evaluation of granules. So basically, we evaluate here mentioned various characteristics of granules, which include the first one, particle size and shape determination, then various densities like that of bulk density, true density and granular densities. Then we determine its flow property like that of angle of repose, percentage compressibility index, Houseness ratio, etc. Along with that, few more tests which are to be performed for granules include moisture content test and percentage fineness. Now, let us discuss all these characteristics and their way to evaluate one by one. The first one, that is particle size and shape determination. So basically, investigating particle properties such as size and shape is important in understanding the deformation behavior of powder under compression during tableting. Then, the size, distribution, and shape of the particle can also affect bulk properties, then product performance, also processability, stability, and appearance of the end product. Along with that, the surface area of solid particle is important to determine the rate of chemical reaction, as chemical reaction is more likely to occur on smaller particles. Particle size analysis technique are useful to plan an experiment or chemically manufacture a product. Also, size affect the average weight of the tablet, disintegration time, weight variation, flowability, right, friability, and also drying rate. Therefore, the various techniques which are used to determine this parameter are the first one, sieving or sedimentation rate or microscopy, or also by using light scattering technique. Then next one, that is density. Density is measure of mass per volume. The average density of an object is equal to its total mass divided by its total volume. Further, density may influence compressibility, further tablet porosity and dissolution. Also, dense hard granules may require higher load to produce cohesive compact to reduce free granules seen on the surface of tablet. And dense granules have less friability but causes a problem in releasing the drug. Further, the instrument which is used to determine density is pycnometer. So these are mainly a laboratory device that are used for measuring density or volume of the solids. The pycnometer is a glass flask with close fitted ground glass stopper with a capillary hole through it. The fine hole releases a spare liquid after closing a top filled pycnometer and allow to obtain a given volume of measured and or working liquid with a high accuracy. Here, the liquids which are generally used include mercury or any other solvent of low surface tension like that of benzene. Also, the liquid should mask granule solubility in it and have property to penetrate the pores. Then density is then determined from volume of intrusion fluid displaced by pycnometer by giving or by given mass of granule. Further, our density can be of three different types. Basically, the first one, that is bulk density. Bulk density of the material can be defined as the ratio of mass to the volume, that is including the interparticulate void volume of untapped powder sample. Here it is given by the formula Pb is equal to m by Bv. Pb is bulk density of granules, M is mass of granules in grams, and VB is volume of granules in measuring cylinder in ml without tapping. Remember, if more compressible bed of particulate, then less flowable granules, and if less dense or compressible, then more flowable granules. Further, the next one is tap density. The tap density or true density is the density that is obtained by mechanically tapping a graduated cylinder containing the sample until no or little volume change is observed on further tapping. It is given by the formula Pb is equal to m by Vb. Here Pb is true volume of granules, then m is mass of the granule in grams, and Vb is volume of granules in measuring cylinder after tapping in ml. Then the next is granule density can be defined as ratio of mass of granular powder and granule volume. Here it is determined by using pycnometer in the similar fashion as we have seen before. Then the next property of granules to be determined is flow properties. So flow property can be said as the ability of granules to flow from hopper to the die cavity for tablet uniformity. Then if a flow property of granules are not uniform, we are not going to get a even tablet of uniform size. Further, the flow property of tablet depends on several factors like that of particle size distribution, moisture, temperature, etc. Then the flow property of material results from various forces like that of basically the first one, that is frictional force, and the second one is surface tension force. Also, a good flowability in a powder is ensured when particle can overcome this resistance to flowing easily without forming any sort of lumps, cluster or aggregates. Some other forces that can be acting on the particle include mechanical force caused by interlocking of irregular shaped particles, then electrostatic forces or cohesive or van der Waals forces. These forces can also affect granule property such as particle size and shape, then particle size distribution, surface texture, roughness and surface area. Then the flow property are when particle size increases, mechanical and physical properties become more important with packing properties. Flow properties of granules are determined by measuring three parameters. The first one is angle of repose, then percentage compressibility index, and the third one is Houseness ratio. Then talking about angle of repose. The angle of repose is the angle that the plane of contact between two bodies make when the horizontal with the horizontal when the upper body is just on the point of sliding and the angle whose tangent is the coefficient of friction between the two bodies. We can also say that angle of repose is characteristic related to interparticulate friction or resistance to movement between particles. Then angle of repose is given by the formula tan theta is equal to h upon r, where theta is angle of repose, h is height of the pile and r is radius of the pile. Then this table indicate the various ranges and type of flow. Let me tell you, the angle of repose can range from 0 degree to 90 degree. If the range of repose is or angle of repose is less than 25, then it is or it offers an excellent flow. If it is 25 to 30, then it has a good flow. If it is 30 to 40, then it's passable. However, if the angle is above 40, it indicates it has a poor flow. Then the next one, that is percentage compressibility index. Compressibility index is measure of the propensity of a powder to be compressed. Here it is directly related to the relative flow rate, cohesiveness and particle size. It is simple, fast and popular method of precising powder flow characters. Percent compressibility index is given by tap density minus bulk density upon tap density into 100, or I is equal to 1 minus V upon V0 into 100, where I is percent compressibility index, V it is volume occupied by powder or granules after tapping, and V0 is volume of powder or granules before tapping. You can see this table indicate percent compressibility index. If the percent what is obtained is between 5 to 15, it offers excellent flow. If 12 to 16, then very good. 16 to 18, it offers good flow. Then 19 to 21, fair flow. 22 to 35, poor flow. 36 to 40, very poor flow. And if the percent what you get is above 40, it indicates extremely poor flow. Then the next one, Houseness ratio. Houseness ratio as such is related to interparticulate friction and as such could be used to predict powder flow characters. Houseness ratio can be given by tap density upon bulk density. This table indicates the various values for Houseness ratio. I apologize. In this slide, instead of percent compressibility index, it has to be Houseness ratio. So if Houseness ratio is in between 1 to 1.11, it offers excellent or very free flow. If Houseness ratio is in between 1.12 to 1.18, it offers good or free flow. Then if from 1.19 to 1.25, it offers fair flow. If Houseness ratio is in range of 1.26 to 1.34, it has a passable flow. Then if Houseness ratio is in between 1.35 to 1.45, it offers a poor or cohesive flow. Then if Houseness ratio is in between 1.46 to 1.59, it presents a very poor or very cohesive flow. And if it is above 1.60, then it offers an extremely poor or appropriately non-flow property. Then the next property of powders, that is moisture content. So moisture content is simply how much water is present in the product. It influences the physical properties of substance like that of weight, density, viscosity, also conductivity and some other properties. The amount of moisture present in granule is called as moisture content. Also, it can be determined by weight loss upon drying, and generally the instruments that are used are moisture balance or IR balance. Then percentage moisture content can be determined using the formula initial volume initial weight minus final weight upon initial weight into 100. Then the next parameter, that is percentage fine. Here fines can be said as the amount of material from sample that are smaller than a certain required size. Then basically percent fine are generally powder remained in the granules. Then percent fine can be calculated by using sieving method, and generally percent fine should not exceed more than 15%. So this is all about the different characteristics of the granules. Thank you for watching till end. See you soon in next video. Thank you.